Welcome! In this series of short videos, we will look at topics for the PowerBasic Console Compiler. Today we will look at creating your first processing project using the Console Compiler. This was our application at the end of the last video. We have created a templated application which will log to a log file when it starts and when it finishes. And each time the application runs, we will erase any previous version of this log. What we're going to do today is we're going to expand on this template to give us something that will do some processing. So let's go and have a look at our code. We are here now in the PB main function, which is the first function your application will execute when you double-click on the executable file. We're declaring two variables, one for the log and one for an error. We're then attempting to erase the log should the file exist, and then we're appending to our log file to say the application has started, and adding on the time. If we are unable to either create or append to that file, we will display a message unable to write the log on the screen, with an error message. We're then waiting a total of 8 seconds before exiting the application. So what we're going to do today is we're going to create a function. This function will perform our processing. The function will return either true or false. If it returns true, then the processing has been successful. If it returns false, then the processing has not been successful. So what we're going to do is we're going to set the value of a new variable called result, either to have the text processing successful or processing unsuccessful. We will then print the value of that variable out to our console. With the majority of console applications, the application itself will have no one monitoring it. It will run unattended. However, for you as a developer, it's always useful to have some feedback from the application on the console to see what it is actually doing. So we will need to declare this result variable. And next, we need to have some idea of what our application is going to be doing. What is the process? For today's demonstration, I want to use some date handling. We're going to take the current date and generate information for the last 90 days prior to today's date. So I'm going to create two variables, one to hold the start date and one to have the name and path to an output file, which will be generated by this process function. So I've created two new variables, one called date and one called output file. We're populating the date variable using date $. Date $, is an inbuilt function to PowerBasic. This always returns in the American date format, as in month, day, year. Doing it this way will allow the application to run regardless if you're using the American or the UK date formats. So next we'll populate the output file variable. And we're just going to call our output file 90-day list. What the processing is going to do is to generate the date and the day of the week for each of these 90 days. And it's going to push them out to the output file, which we can then look at and see if the program has performed correctly. So in order for our process to work, we'll need to pass some information on to this function. So we're going to pass two parameters, the date parameter and the output file location. This can be done quite easily by putting both of these variables in the parameters list, date and output file. It's important to note, unless you specify otherwise, all parameters passed to a function or a subroutine are passed by reference. Therefore, in theory, any change made to these variables within the function or subroutine called will be reflected if you come back later to the calling function. However, we don't plan on making any changes to these, so we're fine to proceed as is. So let's now go and create this process function. And here is the skeleton of our new process function with its two parameters, date and output file. As I said before, these are by default passed by reference. Although I'm keeping the name of these variables the same as the pb main function called them, they do not necessarily have to be called the same thing in your code. However, they will be pointing to the same area in memory, which is worth remembering should you change the value of either of these variables within this function. So within this function, I'm going to be doing some slight manipulation of the console. First of all, I'm going to be changing the caption of our console window, and it will be called File Production. Again, this is just to show you what you can do on consoles. Next, I'm going to change the color of the foreground text to brown by using the color command. If you highlight the color command and hit the F1, you'll see all the possible colors we can have, foreground and background. The first parameter is the foreground color, and as we're picking number 6, this is going to give us a brown foreground. We're leaving the background color as 0, which is the default black. Next, I'm going to set the size of our console to make it 30 rows by 60 columns by using the console screen command. Next, we'll print something out to the console to give our developer a view of what's actually happening by printing out the word processing to our console. So the purpose of this function is to generate information from the last 90 days. So I'm going to declare an array to hold this information. And this is going to be a string array with 90 rows and 2 columns. By default, there is always a 0 element. Declaring it as 90,1 is exactly the same as declaring it this way, from the 0 element to the upper bounding of the first dimension, and from the 0 element to the upper bounding of the second dimension. This gives us an array grid we can actually populate with information. As we've passed the current day's date into this function, and it could be any date we're passing in, we'll want to separate the date into its year, month, and day components. So we're going to create 3 local variables to hold that information, and we're going to populate it using a range of string commands. So there are our 3 variables, year, month, and day, and we're populating it first of all by using the right $. This gives us the 4 characters on the right-hand side of the string, and we're turning that into a number and storing it in the year. For the month, we're using the left $ command, which means you're taking the first 2 characters on the left-hand side of the string, and the final one is the middle characters. It's the 4th character for 2 characters, which in this case is the day of the month. PowerBasic does come with some inbuilt classes to save you some time, and one of these allows you to manipulate dates. So first, we're declaring a variable as iPowerTime, and then setting that to class PowerTime. This allows us a variable which can be manipulated by a variety of methods. So the first method we're going to use is to set the date within that variable. And we do that using the newDate method. It takes 3 parameters, which are the year, month, and day variables we have just populated. So next, we want to work out the previous 90 days to the date we have passed in and stored within our IPDate variable. So we'll first of all try a for next loop. So we're declaring a local variable called d, and we're going to go through a for next loop from 1 to 90 days. And we're going to use another method on this, which is to reduce the date in that variable by 1 day. So it's going to, in this loop, step back 1 day at a time until we've done 90 days. So for each iteration of this loop, we can populate our array that holds day information. So this can be done quite easily by specifying the name of the array, the row, and the column you wish to populate, and by using yet another method in the IPDate variable called dateString. This will return the date in either day, month, year, or month, day, year, depending on the date format you've set up in your Windows computer. However, to aid the readability of your code, it's sometimes useful to use constants. So rather than using a 0, I'm going to use a constant which we will declare at the beginning of our code. So I've created two constants, one called date and one called day. These will be used in reference to numbers to reference the elements in the array. When PowerBasic compiles, it will replace these constants with their actual values. However, having these in the code makes it more readable. We can see we're populating the date element with the date string and also with the day of the week string. So if the date string happens to be the 12th of February 2026, the day of week string will show as a Thursday. So this is the information going into our array. So once this for next loop ends, we can then look to output the information held in our days array to the disk. We will do this by opening the output file and printing the information out to our file from the array. When opening a file, you need to designate a file handle. While you can actually hard-code these into your application, it's always very useful to use the free file command to give you the next available file handle. This saves you writing something out to the wrong file. So we will declare a new variable called fileout, and we will populate that using the free file command inbuilt to PowerBasic, which will give you the next available file handle. So when we open our file for output, we can actually designate the file handle using this variable. I'm going to put the open command in a try-catch block. This will handle any errors in opening the file. If, for example, our disk runs out of space, or there is some locking problem on the file name, then we can handle the error quite cleanly within our application. When you have information in an array, you can print this out to a file using a single line of code. By simply using the print command to print to the file handle, and then the name of the array following this. This will print out every value held within that array. However, I'm just using this for demonstration purposes because in multi-dimensional arrays, it's not particularly ideal. For a single-dimension array, it is positively useful. So should we actually manage to print all that out to the file, we will return the value true to our calling function. If there is some error, then we will go into the catch section of this try-catch block, and the value we will return is false. And the final thing we do in the try-catch block is to close the output file. So as you will see from our pb main function, the name of the output file is going to be 90daylist.txt. So let's try running the application now and see how far we get. And it's telling us the processing was successful, and it's now in the process of exiting the application. So let's have a look to see what we've got. So there is our folder, and there is our 90-day list. As we can see from that, we have a number of records in here. And we have the date, or 90 days going back to the previous day. Today is the 12th, so the previous day is the 11th, and it goes back 90 days, and then after that, it prints out the days of the week. Ideally, we would like to have the days beside the actual date, so we're going to change our code so we don't use the print whole array option. So we're going to comment out that line of code, and we're going to put in another for next loop, again from 1 to 90. So we can print the information from our array out to our file, again using the print command and the file handle. So the first element is the date. I'm using the semicolon at the end of the line to ensure that we do not go into the next line, and the day of the week is actually printed out on this same line. So let's try running that now and see what we get. Again, successful application. If we look at our 90-day list, and there are our dates and our days. This could be a little tidier because we're probably going to want to take this file and feed it into some other application. So let's turn it into a CSV file. We can do that quite easily by using a couple of inbuilt constants that PowerBasic supplies. In a CSV file, you'd expect strings to be wrapped in double quotes. So we're going to use the double quote character added to the beginning of our first element. And then after that, we'll want to have a double quote, a comma, and another double quote. And this can be easily done by using another constant. In this case, QCQ, which is quote, comma, quote. And at the very end, we'll add on another double quote. So we try running this now. And having a look at our output, there is something a lot more usable. We have double quotes round the date, a comma, and then double quotes round the day of the week. So in this, we have 90 records, showing the date and the day. But what if the user who's requested this file does not want Saturdays and Sundays? They only want weekdays. How can we eliminate those 2 days of the week? Well, in the population of our array, we can perform this task. We know what the day of the week is. So we can test for that and only keep the weekdays. We can do this quite easily by using a select case statement to test the value held within day of week string. If it's Sunday or Saturday, then we can use the iterate command. The iterate command will go to the next value in our loop. So since we're doing a for next loop, it would go to the next value without executing these 2 lines of code. So if we run that now, we would get it completed. And if we look at our file, we would see we no longer have the weekends shown. However, there are still entries in the file blanked out. Ideally, we wouldn't want those either. So let's see if we can eliminate those. In our loop, it's a for next loop, so it's going through 90 iterations, which means the Saturdays and Sundays are still processed, but the date is not populated in the array. So we're going to change it from a for next loop to a while loop. So initially the d variable, which is our day, is 0. And we're going to keep going until it reaches 90. And we'll put a case else statement in our select. So if it's Saturday or Sunday, we will iterate. If it's not Saturday or Sunday, we will increment the value held in our d variable. And we will put a when command down at the bottom of our loop. So if we try running that code now, it will still run successfully. And if we have a look in our file, we now have all the days of the week except Saturday and Sunday. And there is no blank entry in the code. And we still have 90 records in our file. So we now have the last 90 weekdays. So as we've now created a CSV file, we'll change the extension of our output file from text to CSV. We can run that, get our file coming out once more. And if we look, there is our CSV file at the bottom here. If we open it up, we can see we now have a quite clean CSV file. We haven't added a header into the file, so that's probably the next thing you want to do. Before we write to our file, we'll put out our headers. So we can do this quite easily just after we open the output file. We're using, again, the print command to print out 2 columns, the date and the day of week. Again, using $double quote and $quote, comma, quote to wrap our text in quotes. If we attempt to run that now and have a look at the file generated, the CSV file, and there are our headers at the top of the file. Date and day of week. And we have 90 records, starting from yesterday's date and going back 90 days. So our application works fine. However, there's a couple of things it's probably worth changing. At the moment, we have 90 days hard-coded into the application in a number of places. First of all, in the loop here at the end, in the loop here where we populate the data, and when we're populating the array. There are a number of ways of getting around this, Possibly the easiest is declaring a constant at the beginning of the application, which would allow us quite easily to change the size of the data we're looking at. So let's go back and do that. So here we have a new constant called max days. And we will copy that in to our processing. So we will change the 90 here to max days. So this will allow us to quite easily change the number of days to process just by changing one line of code at the beginning of the application. We could also copy that constant into these lines of code as well. However, another option you can use is the ubound command. As this is going to be dealing with an array, we can work out programmatically in the code how big the array actually is. We've dimensioned the array up here, so we know the name of our array. So if we put this command in, it would tell us how big the array has been dimensioned to. As this is a multi-dimension array, it has more than one dimension. So we're looking for the first dimension. If we don't put the comma 1, it would assume the first dimension anyway. But it's always good to put this in because you may at some point in the future increase the number of dimensions. And we can go further down in the code and replace the other 90. So now our code is quite robust and easy to change if we want to increase the number of days. But just to be sure it's still working, we will run the code once more and we will have a look at our CSV file. So there it is, still giving us 90 records, still starting on the 11th of February 2026. So in summary, what we've done today is we have added a processing function to our standard template. This processing function will take two parameters, the date we are to start at and the output file it's to create. Within this process function, we're making use of the PowerTime class to allow us to step through the last 90 days. And for each day, we're outputting the date and the day of the week to our file. However, we are excluding Saturdays and Sundays and only keeping weekdays in the file. Hopefully you'll find this code useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.